All right. Well, what we're going to be looking at this evening is parallel lines, perpendicular lines, and the average of a function. So first off, parallel lines. There's sort of an intuitive way we can talk about these, but they're basically lines that never intersect. And we look at these, say, on a flat surface or a Cartesian plane, and they do this. They're going to maintain the same distance between each other the entire time. You can kind of think of them like railroad tracks. Like railroad tracks don't cross, and for the train to traverse the tracks safely, usually you want to make sure these tracks are always the same distance apart, not greater, not small. And the other thing with parallel lines, if we put this in mathematical terms, is this. Two different lines with the same slope. There are two different lines with the same slope. So, for example, let's say we want to find a line. Parallel to y equals 3x minus 1. Well, all we got to do is come up with a line that has the same slope. So, for example, y equals 3x. Both have a slope of 3. Y equals 3x plus 2. Again, slope of 3. Y equals 3x minus the square root of pi. Again, different y-intercept means we've got a different line, same slope. So these are all parallel lines. Now, another kind of question we'll get is this. Find a line parallel to y equals 5x plus 1, excuse me, passing through the point 3,1. Well, what this means is this. A parallel line means it has the same slope. So that means whatever this mysterious line is, it has a slope of 5. And we do have a point. So when we have a slope and a point, we can use our point slope formula. So using the formula, we plug in values for x1, y1, and for m. And so this gives us y minus 1 is 5x minus 15. Add 1 to both sides. And there we go. And that's it. So that's the idea of parallel lines. The other kind of lines we look at are perpendicular. Now, where parallel lines, they follow like train tracks, perpendicular lines, they intersect like roads crossing each other like at an intersection. So perpendicular lines, if you think about an intersection, this is where lines cross each other, where the angles between the lines, they're each 90 degrees. So how do we come up with a line that's perpendicular? Well, this is how it works. If you have a line that's y equals mx plus b, a line perpendicular will have a slope like this. We take the original slope, we flip it, and make it negative. And then x, and you could use any y-intercept, we'll say a. But you could use b also, that would be fine. But we take this slope, what we do, we flip it and make it negative. So the process is m goes to 1 over m goes to negative 1 over m. And that gives you the slope for a perpendicular line, perpendicular to this line. So let's take a look. So let's find a line that's perpendicular to y equals 4x plus 2. So note that our slope is 4. So a line that's perpendicular to this line, we need to modify this m into a perpendicular m. So we take m, which is 4, we flip it, then we make it negative. So any line with this slope will be perpendicular to that line. So you could do this. You could say y equals minus 1/4 x. That'll work. Or we could do this. Y equals 1/4 x plus 2. Now in this case, we don't have to worry about the y-intercepts being different. We had to worry about that with parallel lines, so we didn't really have just the same line, really. Because the slopes are different, we're going to have 2 different lines here. So they can have the same y-intercept, that's fine. All right. So those are perpendicular lines. Another kind, well here, let me do one more example. So here, let me change this up. Make this a little trickier. Make this minus 1/2. So again, we want to come up with a perpendicular slope. So our slope m minus 1/2. Then I'm going to modify m like so. Or take 1/2. We flip 1/2, which is the same as 2. And then we make this negative. So the perpendicular slope is -2. So now we have our slope. We have a point. Again, use the point slope formula. So this will be our x1. That'll be our y1. And our slope was +2. Oh, shoot, did I mention that before? Ooh, I'm sorry. Let me go back. I made a mistake. Let me go back to that slope calculation. Ooh. So m was -1/2. I left off the negative. So if we start with -1/2, that's our slope. We flip this to get -2/1, which is just -2. We apply a negative sign to it. -2 or 2. Sorry about that. I accidentally left off the -2 again. So for our perpendicular line, the perpendicular slope is +2. So for the perpendicular line, and I'll use this symbol for m. This means perpendicular. So y minus y1 equals m, perpendicular m. X minus x1. And then we put in the values for y1, perpendicular m, and x1. So y minus 3 equals 2 times x minus 1. Add 3 to both sides. And there we go. And so this line is perpendicular to that one, and it passes through the point 1, 3. Do one more. Let's say we have this. Squeeze perpendicular in there. Say we have that. Well, in this case, what we're going to do, again, we need a perpendicular slope. So we take our original slope m, we flip it, we multiply it by -1, get -1/4. And so x1, y1, y minus y1 is m, x minus x1. Or y minus 8 equals -1/4 x minus 4. Distribute the 1/4 for the -1/4. -1/4 x. Negative times negative is positive. 1/4 times 4 is 1. So we have +1. Add 8 to both sides. And there's our answer. So those are perpendicular lines. We've looked at parallel lines. Let's look at the average of a function. So what this is essentially, or the average rate of change, I should say, not average of a function. That's actually a calculus idea. We're going to look at the average rate of change. So the average rate of change is defined as this. Let's say we have a function. Now, rate of change means slope. And so what we're coming up with is sort of the average slope of a function. So let's say we have something doing this. And if you follow the slope here, you can use tangent lines. Now, tangent lines contact a curve at one point. So you have a tangent here, and then here, and then here, and then here, and then here. If you notice the slope of this tangent line, it's always changing. There, there, there. So that means the slope of this curve is always changing. So we just want kind of an average slope. And what we mean by an average slope, if you're going to draw a line through this portion of the curve, what would be the slope of that line? And that's what we mean by the average. So what the average would look like would be this. Say we take a point here, and say this is at x1, and this is at x2, and this would be f of x1, this would be f of x2. So what we would get, the line going through here would look like this. And so that's kind of a sort of average approximation of this curve, for better or worse. Maybe not terribly great. We might try to do a little better. Put x2 over here. Oh, that might be a better average for between this x1 and that x2. But I mean, you could do it up here too. You could do that. But for, I guess, visual aesthetics, we'll put it right here. All right, there we go. So roughly the line is following that trend. So when we talk about the average rate of change, we're talking about the slope of this line. We're using to roughly describe the path of the function, how the function's traveling through space. And so we compute a slope. So this will be our y2 to go with x2. This will be our y1 to go with x1. So y2 minus y1 will be f of x2 minus f of x1 and x2 minus x1. And this slope is the average rate of change. So let's do an example. Let's take a look here. So find the average rate of change for, well, let's say, f of x equals x squared plus 2x from x1 equals 3 to x1, or x2 rather, equals 7. Let's say we're going to do that. Well, our formula is f of x2 minus f of x1 over x2 minus x1. Well, we've got x2 and x1. There's x2 and there's x1. Let's get f of x1. So f of x1 is f of 3, which will be 3 squared plus 2 times 3, or 9 plus 6, or 15. F of x2, well, that's f of 7, which will be 7 squared plus 2 times 7. And that's 49 plus 14, 59, 63. So putting this all together, f of x2 was 63. F of x1 is 15. X1 was 7. I'm sorry, x2 was 7. And x1 was 3. So there's your x1 and there's your x2. So subtracting these, we get 4. Let's see, 63 minus 15 is 53 minus 5, 48. And then 48 divided by 4 is 12. So the average rate of change of x squared plus 2x over the interval 3 to 7, the average rate of change is 12. All right, well, that's it for this evening, kind of a short section, but we'll be putting out some more videos shortly. Have a good evening.